Hey guys, this video will step you through the second part of section 2.3 while we were working on equations of lines on the first part. This will take you through the special segments of a triangle. There are 3 special segments, and I guess I'm hoping maybe you're watching the video. If you're using your iPad for all of this, you're maybe splitting your screen to watch the video on part of it, on half of it, and then filling in the notes on the other half. But you can pause the video and rewind it to replay as you need to. All right, I'll first go through the sort of an exploration with these 3 segments. The 3 segments are called medians, altitudes, and perpendicular bisectors, as at the top of this page. So hopefully you have this note sheet handy. And we're going to use some interactives from the book to help us figure out what is a median, what is an altitude, and what is a perpendicular bisector, which we've talked about already. So that one you probably know something about. So I'm going to flip back and forth between the book and Notability in this video. So you can either watch that or you can try it also in the book. So here's page 94 in the book. And the interactive on the left is the medians interactive. And when it loads, you can just click on one median and it will show you that first median. And so play around with points A, B, and C and try to figure out what is a median. Add the others if you want to. You can see what happens when we have 3 medians. But I like to just keep one and try to figure out what the heck's going on with that one. And hopefully you can see it goes from a vertex, always from a vertex, to a specific point on the opposite side. And hopefully you see that is the midpoint. Okay, so that's to start there, and then I have that filled in here. So you might want to define it on your sheet as a segment from a vertex, from any vertex to the midpoint of the opposite side. And there's a little diagram picture for you to see it. So feel free to pause and write that in if you want to. And then when you're ready, we can go and figure out what an altitude is. So I'll move on to the next interactive in the book, which I think is on the next page. Yeah. So at the top left, you see there's an interactive called altitudes. And, if you've been in a plane before, you know planes fly at a certain altitude. And in that case, that's the height that you are above sea level. And in this case, if I show an altitude, I'll show altitude number 3. That's the altitude from A. That is also the height of the triangle from point A. And you notice an altitude can leave the triangle too. When it's an obtuse triangle, the altitude or the height of the triangle is actually a vertical segment outside the triangle. And then if it's a right triangle, look where the altitude is. And then if it's an acute triangle, the altitude would be on the inside there. You can also show the other altitudes. Those are just the heights if it was a different base. So if the base was, let's see, if the base was AC in this triangle, well then the height of the triangle would be from B, a perpendicular segment, to AC. And likewise, if we considered the base to be AB, then the height of the triangle would be from C, perpendicular to that side. So that's kind of cool. It's like altitude is sort of like height of a triangle. And somewhere in here I have this one defined as well. So an altitude is a segment from a vertex that is perpendicular to the opposite side. It may or may not pass through the midpoint. Okay, it may or may not pass through the midpoint. So go ahead and pause and write that in if you'd like to. The definition of an altitude. Those can leave the triangle. And finally, perpendicular bisector when you're ready. So perpendicular bisector, I'm going to get out of that one and go to the final interactive in the lower left. And here's perpendicular bisector. So I'm just going to take one of them. This is the perpendicular bisector of one side of a triangle. So think about those 2 words, and it kind of defines itself. A perpendicular bisector is perpendicular to a side, and it cuts it in half, or bisects it. So that means it passes through its midpoint. And so you can play around with that if you want. You can make it hit the vertex right there, but it doesn't have to pass through a vertex, right? And you can add in the other perpendicular bisectors if you like, kind of see what the heck happens with those. But just having one perpendicular bisector to me makes it the most clear. It is perpendicular to a side of a triangle, and it cuts it in half or bisects it. So passes through the midpoint. So then I'll define that one, and you can write this in your notes as well. So there are all three segments defined, although perpendicular bisector ends up actually being a line, but we do call it one of the special segments. So it's a line that passes through a midpoint of a side of a triangle and is perpendicular to that side. And that's what's written there in purple, also with a diagram. And then at the bottom or the middle of the page here, it says use the interactives to figure out which segments might leave the perimeter of the triangle. And so from my pictures up above, you can tell the purple, the perpendicular bisector, definitely leaves. And then we also saw in the interactive that the altitude also leaves. So the two that can leave the perimeter of the triangle are perpendicular bisector and altitude. And these will be used, guys, throughout first semester. So we'll keep bouncing back to these three terms. So do your best to try to sort of memorize them or practice the definitions of each. And we'll be writing equations of these now in this video. So at least you'll get some practice with that. And they'll keep coming up as we move throughout the units. So I thought first it makes sense probably let's draw and label one of each. So let's go green and then blue and then purple. So for green would be a median, goes from this point to the midpoint of the opposite side. There's my median, okay? And then let's go blue. I think I did blue for altitude. Altitude would be straight down, perpendicular to the opposite side, passing through a vertex. And finally, purple is my color for perpendicular bisectors, and it is perpendicular to and bisects a side. So that purple one is a perpendicular bisector. So if you want to write in each one of those, the purple is the perpendicular bisector. The green is the median, passes through a vertex to the midpoint. And the blue is an altitude. Okay, right angle with an opposite side passing through a vertex. All right, so the meat of this lesson is really using our algebra review to actually write the equations of these three. So if you flip to side 2 on your note sheet, this problem is actually taken from page 96. So you can, in addition to watching this video, if you want to read those hints and solutions there, you can. But let's find the median from B to AC. So starting from B, I'm going to be doing a median, which means I need the midpoint of the opposite side. So here's my median. I'm just drawing it in. So it makes sense to me to first find the midpoint of my opposite side. So I'm going to find the midpoint of AC. And to do that, remember, we just average the x's. So add them and divide by 2. So that's 6 divided by 2. And average the y's. So that's 10 divided by 2. So in this case, it's a really nice midpoint of 3, 5. And then my segment is that black segment. It passes through B and this midpoint, I'll call it M. So here are my coordinates of M right here, 3, 5. So I'm going to write the equation of the line from B to M. That's my goal now. If I write that equation, then I have the equation of the median. So I need my slope from B to M. So I'm going to say slope from B to M. And let's do the rise. So the rise would be 5 minus 2, which is 3. And the run, which is 3 minus -4, or 7. So that slope is a little bit of an ugly slope, but that's okay because it doesn't tell us to put this line in any particular form. So my plan is just to use point slope form. And I think I'm just going to make it run through point M. So I'm going to say y minus 5 equals the slope, 3/7, times x minus 3. There's my equation of that median. I put it in point slope form because to me that was the easiest way to do it. Okay, again, feel free to pause and rewind if you need to replay it. That's finding the equation of a median. You have to find a midpoint and then write the equation of the line through those 2 points. Okay, altitude now. Same picture, but altitude from A to BC. So I'm going to change my color to green. And I'm going to draw an altitude from A to BC. So it looks like perpendicular-ish like that, passing through A. Maybe that's not fantastically perpendicular. Something like that. and then I'll make a right angle here. So my altitude looks something like that. And so what I need is to find a slope of my altitude. So for my slope, remember, the altitude has to be perpendicular to BC. So I'm just be thinking about a perpendicular segment to BC. So that means I need the slope of BC. So I'm going to find the slope of BC here by doing rise over run. So 3 minus 2 is the rise. Oops, 3 minus 2 is 1. And then 5 minus negative 4 is 9. So I believe my slope of BC is 1/9. And that's my dog getting a drink of water, if you can hear that in the background. Dexter. Okay, so then the perpendicular slope, so my new slope, is the opposite reciprocal of 1/9, which is -9. Flip it and change the sign. So I need to know the equation of the green line, the green segment, I should say, passes through point A and has this slope. So I'm going to write down here that I know it passes through point A and it has a slope of -9. So let's choose point slope form unless it tells me a different form that I have to use. So there's my point slope form equation. Now, you could leave it like that for sure. So I'll put a box around it, say we could leave it like that. However, if the question does say something like write it in slope intercept form, well then you might have to go further. So I'm going to go a little bit further to put it in slope intercept, even though this question doesn't say to do that. So I distributed the 9, and I'm going to add the 7 over. If I add the 7 over, so in slope intercept form, this altitude has an equation of -9x plus 16. So I didn't have to do that in this problem, but in case there's a problem in the homework maybe, or on the other note sheet that asks you to put it in slope intercept form, then you just have to continue to distribute and get like terms so that y is all by itself. Okay, so there's an altitude, that's the green one. And finally, the perpendicular bisector of BC. Okay, so let's change to purple and let's go up to BC. What we're going to be finding is the midpoint of BC. I don't know exactly where that is. And we're going to be finding a perpendicular bisector. So it's got to be perpendicular to BC. What's cool about that is we already know the slope of BC from doing part B. So I'm going to take my slope. So this slope of my perpendicular bisector is going to be the same as the altitude above because it has to be perpendicular to BC. Okay, and then I have to find my midpoint of BC. So I'm going to do some work here to find the midpoint of BC. And so that requires me to add the coordinates and divide by 2. So this is not a nice midpoint. Adding 5 and -4 is 1 over 2. And adding 3 and 2 is 5 over 2. So I just use points B and C to find the midpoint of BC. And now I'm good. I have the slope, I have a point, so let's write it in point slope form unless it tells me I have to do a different form. So here's my point slope form final answer for part C. Okay, so now you've seen one of each type, a median, an altitude, and a perpendicular bisector. Let me just look at number 2 for a minute, and then I'll wrap up this video, and then see the instructions on Canvas for what's required of you to finish the lesson for today. So I'll go green. Let's go. A is 0, 1. Right there is point A. B is 0, 5. And C is 5, 2. Okay, so here's my triangle. Okay. And so if I want the altitude from C to AB, remember this is C, this is B, and this is A. The altitude, I'll go blue for altitude, would be a perpendicular through C, right angle at AB. So that's that blue chunk, and I can see that easily. That's y equals 2. That's a horizontal line at a height of 2. And then the median from C to AB, well, the midpoint from C to AB is not too hard. Let's go red for this one. The midpoint is going to be between 1 and 5, so it must be that one. So there's my midpoint. That means that's my median. And just by looking at it, I can see that the slope of that goes down 1 and over 5. So the slope of the red segment is 1/5 negative. And its y-intercept is at 3. So I can write it in slope-intercept form pretty quickly without too much work. Negative 1/5 x plus 3. And then finally, if you put those two together, meaning the slope of the altitude, which is 0, and the midpoint of the median, that gives us the perpendicular bisector. Notice that purple. It does not pass through the vertex, but it is perpendicular to and passes through the midpoint of BA, or AB, and that's y equals 3. Okay, so you've seen a couple examples of altitude, median, and perpendicular bisector. Hopefully this helps you with the note sheet that's required for submission for today.